The real shift this week is that flow-based image models are no longer just getting better, they're getting controllable. We're seeing unified effect editing, direct reward optimization, and safety control all move into the same few-step generation regime, which matters because that's where deployment actually lives. In plain English, fewer steps, less latency, less memory, and much more precise steering without wrecking image quality. Stick around, because the interesting part is not that these systems can edit and optimize, it's how they're being made stable enough to do it at scale. Let's explore the first paper, Collection LoRA, collecting 50 effects in one LoRA via multi-teacher on-policy distillation. Collection LoRA from Zhejiang University and Alibaba's Quen Applications Business Group reframes customized diffusion editing as a multi-teacher on-policy distillation problem and compresses up to 50 effect-specific LoRAs plus few-step generation into one LoRA, eliminating routing latency, storage growth, and parameter conflicts that cause concept bleeding and style drift. Built on Quen Image Edit 2509 with distribution matching distillation, it adds probabilistic dual-stream routing to mix effect data with 20K general domain images, asymmetric orthogonal prompting to separate teacher and student concepts using VLM rewritten prompts and orthogonal trigger words, and a course-defined distillation objective that combines flow matching trajectory anchoring with target simulation to prevent distribution collapse. On EffectBench, its 8-step unified model reaches CLIP 0.727, DreamSim 0.425, Edit Reward 1.052, VSA 4.380, and BCR 0.087, outperforming the 5.0-in-1 flow matching baseline and reducing deployment overhead to 0s. Q routing latency, with 100% routing accuracy for 1050 LoRAs. The method scales to 180 effects, where storage drops to 2G times 3, and routing accuracy remains 82%. And it also shows zero-shot composition. 2 learned effects can be chained at inference without additional training. Let's explore the second paper, exploring the design space of reward backpropagation for flow matching. This paper from Tencent Hanyuan, Westlake University, and the University of Sydney studies direct reward backpropagation for text-to-image flow matching and identifies 2 failure modes in prior methods. Full trajectory activations are too expensive to store, and multi-step Jacobian chains destabilize gradients. The proposed FlowBP framework turns the backward trajectory into a surrogate design problem, separating reward model input, active set selection, integration weights, and bridge coupling, and it recovers ReFL, DRaft-LV, DRTune, and LeapAlign as special cases. 3 new variants are introduced. FlowBP Sparse reconstructs the endpoint with sparse Euler updates. FlowBP Bridge adds a controlled 1 Jacobian bridge, and FlowBP Lagrange replaces LeapAlign's single velocity leap with higher order Lagrange quadrature. Across SD, 3, 5, M, Flux, 1 Dev 12, B, and Flux, 2, Klein, Base, 9, B, the methods improve HPSV2, 1, pick score, image reward, UR-align, and URIQ on most metrics. For example, on Flux, 1 Dev, HPSV, 2, 1, rises from 0.3016 to 0.4134, and Gen Eval improves from 63.25 to 69.888 F. While the authors report that memory scales with active set size rather than rollout length, and gradient chaining is bounded to at most 1 Jacobian factor. Let's explore the third paper, Safe Few-Step Generation via Velocity Editing. Safe Few-Step Generation via Velocity Editing by Yu-Jin Choi and Jae-Hong Yoon of NTU Singapore and UNIST introduces VES Flow, a training-free safety method for flow matching text-to-image models such as Flux and MeanFlow. Instead of steering the sampling trajectory with per-step negative guidance or editing prompt embeddings, VES Flow directly edits the model's marginal velocity field toward a safe conditional posterior using a Bayes-derived score term, which is especially suited to extremely few-step generation. The paper's key insight is that few-step samplers cannot accumulate small corrections reliably, while modern T5-based text encoders make toxic concepts hard to erase in embedding space. VES Flow adds a risk score filter that skips velocity editing on benign prompts and proposes VES Flow Plus, a stronger contrastive variant that both attracts trajectories towards safe outputs and repels them from unsafe ones once a prompt is flagged as risky. On the 4-step mean flow model, the method cuts new net attack success rate to 15.2% on Ring a Bell and 7.5% on MMA diffusion, and Vest Flow Plus lowers those further to 6.3% and 6.8%. On Flux with 8 steps, VES Flow reduces Ring a Bell nudity ASR to 26.6% and VES Flow Plus to 1.3%. The method preserves benign quality, with MS Coco 10K FID and clip staying essentially unchanged, and it is lightweight enough that prompt-level filtering removes most added cost on safe inputs. That's a wrap on today's AI paper highlights. Thanks for watching.